So in trying to graph a sinusoidal function to graph the amount of daylight hours in each day of the year, we need to start with the given information. We were given this chart that shows the amount of daylight hours and the date. We are also given that December 21st has the least number of daylight hours and that June 21st has the most number of daylight hours. With this information, we aren't able to conclude that it is periodic because there aren't any repeating numbers. But from common sense and from living on the earth, we know that this is a periodic function and is repeated every year. So we can find a sinusoidal function to graph this equation. So now that we know that the information given is a periodic function, now we need to find the function that will actually output a graph that represents the daylight hours per year, per number of days. So we need to put it into the form f of t equals a cosine b of t minus h plus k. And we know that the a value is the amplitude of the function, and with the previous data given that June 21st has 15.27 hours of daylight, and that is the max, and the minimum is December 21st, which has 9.07 hours, 9.07 hours of daylight, we need to find the midline. And once we find the midline, in between the midline and the height and the min will be a value, and that is the amplitude. And upon doing that, it will give us 3.1. And the b value is telling us how long or horizontally compressed or stretched the function is going to be. And since the function is supposed to give us the number of daylight hours in terms of days, a year is 365 days. And that will give us 2 pi over 365 for a b value. And since the minimum lands on December 21st, our function needs to start on the first day of the year. So we need to start by shifting it over 10 days. And to do that, we need to give a proper h value of negative 10. And since the midline of the function is 12.17 hours, that'll be our k value, so we're shifted up that many. And when we put this into the equation, or previous format, it should give us a clear equation that'll help us graph the number of hours of days, numbers of hours of daylight per year in days. Oh, and also since I'm gonna choose to use cosine because it usually starts at its maximum at x equals 0, but since the number of daylight hours begins at its lowest point and goes up throughout the year, or not at its lowest point, but at close near the bottom and goes up, what we're going to do is use a negative cosine value. And to do this, we just make our a value negative. And since we've already shifted in our h value, it'll be clear and we'll start at the first day of the year. So f of t equals negative 3.1 times cosine of 360, or 2 pi over 365, t. And since that's negative, we also have a negative here that goes out to plus 10 plus 12.17. And upon graphing this, we should get a clear function that'll tell us the number of hours of daylight we will get in a year per day. So now that we already have our equation, we need to graph it. And since we've already clearly listed out all of our values, we need to start by locating the mins and maxes of the function. And the midline is given in the k value, which is 12.17, and we will go ahead and mark that on our graph. And then we can go ahead and mark our mins and maxes. And the minimum will just be 3.1 down from 12.17, and we'll mark that right here. And our max will be somewhere around 3.1 up here. And those values are 15.27. And then our other one is 9.07. And these are all hours per day. And then on the bottom, we will draw out our time, which is going to be, I guess, in years. This will be 1 year or 365 days. We'll also go ahead and write a dotted line for our maximum here, and minimum line for this right here. And now we can proceed to graphing it. And since we've already set up our b value right here, this just tells us that we will be, it takes one period is 365 days. And yeah, so let's get to graphing it. So we notice it's a negative cosine. Cosine usually starts up here and goes down and back up for one period. But since this is a negative cosine, we're going to start at the bottom and go back up and come back down. Usually you would start at x equals 0, but since we are shifted, I believe 10 to the left, we won't be starting right at our minimum. We're going to be starting a little bit higher up, and then we're going to proceed to going all the way up to our maximum and all the way back down to our minimum a little bit before 1 year, and then come up a little lip equal to this value right here, right at 1 year. So we can go ahead and mark some of these key points. So right about 10 days after half a year will be where we will hit the maximum, which is right around here. And we have some other important values here and there where we're crossing the midline. And then we will have, move these a little bit closer so it fits where I put a year mark. And then we'll come a little bit up, and that'll mark our 1 year. So we can go like this. And that's the amount of daylight hours in 1 year. We can see that in the early months, in kind of January, February, March, we have less hours of daylight, and that slowly increases. So where we hit June, somewhere in the middle, June 21st, is a summer solstice, which is the longest day of the year, which will mark our height. And then we'll hit the midline again, and we'll come back down to hit our minimum at December 21st. We'll be right here, and then we'll come back a little bit right up here to end our full cycle of the periodic function that gives us the amount of daylight hours per year in days.